Dear students, I welcome you to our class again, and we are still on projectile conversation. So this question is from past question, WAEC 2018 specifically. The question is A and B. The A part of the question says that we should state the conditions for which a projectile, the condition for a projectile to achieve maximum range. And the B question gives, some values, and it asks us to calculate the range. Now, to solve this question, always note that, remember that number one of the conditions for a projectile to achieve the maximum range is when the angle of projection is 45 degrees. So when the angle of projection is 45 degrees, it's said to, for the range of a projectile to attain its maximum range. So another condition for maximum range to be attained by a projectile is 2, when air resistance is neglected. Neglecting air resistance. So when air resistance is neglected, it means there will be little, control over a projectile by the atmospheric wind and the air around the surroundings. So neglecting air resistance is also another factor, that can propel a projectile to attain its maximum range. And the last one is a projectile, landed on the same horizontal plane as the point of projection. So when the projectile starts its, projected from this place, this horizontal plane, and it's landed on the same horizontal level, then it's also said to attain what we refer to as the maximum range. So the three factors that affect the maximum range, or the conditions that must be met for a projectile to attain maximum range, are the angle of projection must be 45 degrees, we must neglect air resistance, and the projectile must land on the same horizontal plane as it's projected. So the B part of the question, we have to calculate the range. And what are the parameters given? We are given the initial velocity, the speed of the projection as 15 meters per second. We have the angle of projection as 30 degrees, and we are to calculate the range. Always remember our G is 10 meters per second square. So from here, we can say that the formula to calculate range, we have used it in our previous example questions too, is U squared sine 2 theta over G. And from here, we can say that R equals to, what is our U in this case? 15 squared multiplied by sine 2 multiplied by 30. Now our theta is 30 divided by 10. We have divided by 10. So 15 square is 225 multiplied by sine 60 divided by 10. So our R equals to 225 multiplied by sine 60 is root 3 over 2, all divided by 10. From here we can say that R equals to, if we divide this by 10, we're going to have 22.5 multiplied by root 3 over 2. What we divide by 2 further? We're going to have, 2 in 22 is 11. Then 2 in this we have 2. Then we have 5. When we say 2 in 22 we have 11. 2 in 5 is 2. It's remaining 1. Then 2 in 10 we have 25. So our range is 10.25 root 3 meters. So please always remember, whenever you are calculating your either range, your maximum height, always remember that the unit is meters. When you are calculating either time to reach the maximum height or time of flight, always remember that the unit is in second. So this is the solution to this question, and I do hope that you understand. If you want to test your level of understanding of some of these things, get some other similar questions to most of these things we are solving. WAEC questions, NECO questions, UTME questions, and all of these topics will come in similar form, just figures might be different. So try as much as possible to do as many more questions as possible to complement the one I'm explaining to you. And I do believe that you are going to excel in your exam. See you in the next episode.